Hey everybody, we are recording and I'm John Shutsky. I'm an agricultural safety and health specialist with UW-Madison. I'm in the College of Agriculture and Life Sciences, and I'm also a professor in the Department of Biological Systems Engineering. So this presentation is one in which I initially prepared this as part of the 2023 Symposium here in Wisconsin, up at the Wisconsin Dells, involving a number of different groups. The Midwest Forage Association, the Custom Applicators, and also people who apply manure. So welcome. I got snowed back here in Cross Plains, just west of Madison, which is where I live. So agreed to record this, and I'm happy to do so. Today I want to talk about safety risks and new technology, autonomous equipment, robotics, or another, I guess, maybe more appropriate subtitle is agricultural technology. What is coming and what stands in the way? Now, I want to be a little bit careful on this presentation because this is not going to be a how-to. It's not going to be a nuts and bolts of do this, don't do that, like a safety presentation, as you might be maybe expecting. I don't really know for sure. Instead, what I'm going to talk about is how new autonomy, new forms of highly automated agricultural equipment could really benefit us significantly in terms of safety benefits. But the other thing that's important to know is as we think about all these cool things that are coming down the road within the next 5 to 10 years, one of the things we need to think about is safety. I'm really quite concerned about some of the activity, particularly in other parts of the country, not necessarily here in Wisconsin, but a lot of the concern, a lot of the barriers that industry is working hard to try to overcome are in fact connected to safety and risk assessment and regulation and insurability and some of those kinds of things. So I want to give you a little bit of a perspective on what is happening. I will give you a few sort of like tidbits and tips and those kinds of things, but this is largely a big picture. How does safety enter into this whole equation with all of the cool stuff that's coming down the road with technology? I do appreciate you watching this. You might wonder, what's the connection between this and my other presentation, which was done as part of the symposium? Well, as a safety specialist, I come at things from an engineering perspective, but I also am always looking at the interface between people, machines, or technology or systems. That would include like a ventilation system in a dairy barn, as an example. And then how does that relate to the hazards that we face in agriculture, which I will talk about here in just a few minutes. And so that includes stress, that includes human factors, that includes aging, people who are very old working in agricultural businesses or in farming directly, or also people who are very young, including children. The other thing that I want to just note for you before we get rolling here is I'm going to have two different views. Obviously, I'm in the lower right-hand corner for you, and I'm also going to switch to this view. So if you see me suddenly disappear, that's not a technology failure. That's basically because I'm moving on to the next slide, or maybe it's also because my talking head does not fit neatly down in that right-hand corner. All of that said about this not being a technology or a safety tips presentation, I do have some material that I think might be useful for you. I put this together several weeks ago, actually prior to the Louisville Farm Machinery Show. I worked with a number of partners, including Progressive or the Farm Progress companies with Willie there. Sarah is from out of state. She's another extension specialist who works on some of these issues. And also Dr. Brian Luck here in Biological Systems Engineering, my colleague here in our department. It's called 12 Things You Can Do When Moving Forward to Higher Levels of Technology. There's a little bit in here on safety. There's a lot on employees, on employment, on labor. So I think this is quite applicable whether you are farming or running a custom operation, a custom service operation, you're a cooperative, whatever it might be. I think that there are some things here that might be quite useful. And if you look down below in the YouTube kind of show notes, so to speak, I will make sure that I link these various articles. Let me turn my little image off and I will go ahead and plow into the presentation. my outline for today, I want to cover these things. First of all, I'm going to talk about some of the current issues in farm safety. These are some of the driving forces that are pushing us more and more towards higher levels of technology. This is connected to the idea of risk and what I'm going to call D3 work. I'll come back and talk about that in a minute. What is D3? And that includes the potential or the possibilities with new highly automated machines. I will provide for you a few examples, some cool things. I don't think I mentioned this, that I'm actually working very closely with my colleagues at other universities around the country, places like the University of Illinois down in Champaign-Urbana, Utah State actually, and especially out in California, which is where there's a lot of activity related to smaller startup companies, but also big companies that are entering into the California agricultural world, again, both on the production, that would be farming and ranching, but also on the ag services side as well. So I'll talk about some examples, and then I will also talk about what it is going to take to move forward. I would really like to give special thanks to USDA and the National Institute for Food and Agriculture. They have funded a lot of this work. It's an exciting time. It's actually really cool to be at the forefront of some of this the new stuff that's happening in agriculture. I always begin my presentations by talking about risk in agriculture. Is there really a more risk-filled industry beyond what we do in farming and the agricultural services? We are dealing with issues of workplace safety. As you know, I'm quite sure, right now, labor is a huge issue, and that includes the availability, the cost, being able to compete with other non-agricultural or ag service companies for that limited labor supply. And I think that that is likely to only get more competitive in the future. In agriculture, for a range of reasons, we have this huge amount of economic uncertainty. We could go deep on that, right? We could talk about policy, and we could talk about weather, and we could talk about all different kinds of factors. The bottom line is there is a lot of risk, and that includes not only workplace safety, workplace risk, but also economic risk as well. There is also a tremendous cost to change, whether that means getting into a business, getting out, expanding, changing, reconfiguring. When we make the investments that we are talking about here today, and some of the examples that I will show you, we're not talking about something as small as putting a $6 app onto your smartphone. We're talking about investments that can cost businesses or farm operations hundreds of thousands or certainly millions of dollars. Is not all that uncommon. So the bottom line on this is probably not. There is probably not a more risk-filled industry. When I think about risk, historically, if I look at my career over the last 35 years, I've thought about workplace safety. And I think it is important that we just touch on that briefly. If you look at Wisconsin, the last 4 years, in my program, I work closely now with the National Farm Medicine Center. They're located up in Marshfield, Wisconsin. And about every other year, we do a really deep dive. And I would call this almost a CSI style investigation, where we really look closely at things that are happening in terms of farm fatalities and farm injuries. And so you can see the numbers here. These are fatalities or deaths that are directly connected to the farm workplace. By the way, this includes highway travel. As a safety reminder or a safety tip, it is a huge issue. And as equipment becomes bigger and bigger, I'm quite concerned about it. Some of our state level regulations and requirements are really not up to full speed. There are some superseding or they go over the top of the state regulations that are relatively new from the federal government. From the National Highway Traffic Safety Administration on newer equipment. And that's really beyond the scope of this presentation. But there's a big, highway travel is a big contributing factor to this large number of deaths, fatalities that we see. In not only Wisconsin, but nationally, our fatality rate is about 7 times higher than it is in all other industries combined. That's, I don't know if I would call that embarrassing, but it is definitely something of great concern to those of us who work in agriculture. As you see from the data, typically we have 25 to 35 or as many as 40 or 41 deaths per year. The other thing that's quite concerning, and you could also look at the parallel in ag service industries, again, custom operators being an example, about 1 in 5 of our operations has a serious injury per year. When I say serious, about 80% or 4 in 5 require some type of professional medical care and medical treatment. So the bottom line is in the workplace, whether it is a farm or an ag service provider type of an industry, there's a lot of dangers. There is a lot of risk. And generally, much of agriculture, again, both sides of the equation is what I'm going to characterize as D to the third power, D3. D3 industries or D3 jobs or tasks are those which we would typically consider to be a combination of dull, dirty, and dangerous. Now, I want to be really careful as I talk about this because I was born and raised on a farm. I began doing farm work at about age 11 or age 12, and I would not give that up for anything in the world. But the bottom line is attracting people into these industries right now can be really, really difficult, and I see that continuing into the foreseeable future. Let me get rid of my picture there myself. Again, D3 industries, these D to the third power industries are those which have gradually moved towards automation and technology. The most talked about examples right now are manufacturing and mining. So mining, when I started grad school a number of years ago, mining was head and shoulders above the ag industry with the fatality rate that it wasn't quite double agriculture, but it was quite a bit higher. And gradually, these other industries have moved towards more automation. If you go to, for example, a car, an auto assembly, or a pickup, where they make Ford F-15s, Ford F-150s, what you're going to find is, or F-16 fighter jets as another example. When you go to those industries, they are using a huge amount of automation. A lot of the labor that used to be done by hand, it was done by welders and people who were doing manual assembly. A lot of that is now being done by machines. The same in mining. So what you see in this picture from Caterpillar is a self-driving, a fully autonomous mining truck. And again, these are vehicles that maybe 10 years ago were driven by people. Increasingly, construction, including highway construction, building construction, is moving towards automation and autonomy, not entirely, but we're heading in that direction. And I do foresee agriculture heading that way fairly quickly, not necessarily being driven by the labor issue or by the safety issues, but being driven by the labor issues in particular. Now, so we talk about innovation, we talk about automation, and it's important to note that there's a lot of different things that have always transformed agriculture, going back 200, 300 years. These are a few examples. I'm not going to go through all of these, but on the machinery side, you've got the cotton gin, steam engine, the tractor. Eventually, after we had tractors, we moved towards, instead of transmitting power by belt, we moved to power takeoffs. We have hydraulic systems. Now we have, fully self-propelled harvesting equipment. And it used to be that we pulled things in the past. My dad pulled corn pickers and, silage harvesters were pulled implements. And now we're rapidly moving. I'll talk about electrical and electronic monitoring and control. But this is the direction that we are moving. And we have always moved toward more technology and more innovation. I want to just pause for a second and have you look at the little asterisk by cotton gin. So cotton gin was a way of processing cotton, invented back in the late 1700s, really came to speed in the early 1800s. And the cotton gin, while you would think of it as an amazing technology, amazing innovation, it had some negative consequences because the cotton gin suddenly made cotton so much more profitable. It also drove the demand for slaves who could work on the farms to produce the cotton, to pick the cotton, and those kinds of things. So my point in telling you this is as we move towards higher and higher levels of technology, there are a lot of benefits, and I'll talk about those benefits as we go forward. But we also have to be thinking about maybe some of the other unintended consequences in our communities, our educational systems, our local businesses, big and small, and make sure that we're thinking about it from a larger scale, sort of societal perspective. And that's part of the effort that I am helping to lead at a national level, is we look at the safety, we look at the economics, but then we also look at these other economic and community impacts. So this particular slide is technology in livestock. I don't want to spend a lot of time on this, but if you are affiliated with livestock production, dairy production, especially on this sort of right-hand side, you'll notice some companies there, DeLaval and Lely and other companies that are really heavily into the dairy space. A lot of pushing being done on modernizing farms with robotic, like you'll see in the next picture, robotic feeding systems, feed pushers, and obviously automated milking systems. And a lot of this right now, at least on the dairy side of the equation, is being driven by labor. Not necessarily by safety, but definitely by labor and the concerns about labor. I think that in the dairy industry here in Wisconsin and throughout the Midwest, we really are kind of wrestling through where this goes. And I know that right now there's probably not a real clear consensus. It probably is also going to depend quite a bit in the future on labor policy, immigration policy, and our ability to actually bring workers into places like Wisconsin to do some of these D3 jobs that other people in smaller or medium-sized rural communities don't necessarily want to do. This is the crop side of the equation. I don't expect you to study this. You might think, oh, the crop side looks a little bit simpler and a little bit less crowded. And the reason for that is because on the crop side, that data, or that chart that you see on the video here, is from 2022. The livestock piece was from 2018, where you saw more companies. And the reason why the crop side looks a little bit cleaner, a little bit less busy, is there's been a large amount of consolidation. Consolidation, or and maybe another way to say this, is we have small companies that are building and inventing and developing machine learning software and algorithms and hardware that goes with it for field operations, or maybe it's orchards in California, other types of crop production situations. And those that show great promise are then being snapped up or bought up by some of these bigger companies and some of the bigger players, including some of those that you probably will recognize. Obviously, John Deere in this particular instance. I wanted to talk about John Deere not in terms of the whole consolidation or buying up startup companies, but more so to talk about how in 2022, they were a showcase, or one of the showcase businesses that exhibited at what we call the Consumer Electronics Show. The Consumer Electronics Show happens every year in Las Vegas, and it's a big deal. It draws, most years when we don't have a pandemic or other types of issues going on, it draws several 100,000 people. The Consumer Electronics Show literally takes over the whole city of Las Vegas. And as the name suggests, consumer electronics, we typically think about TVs and smartwatches and smartphones and cell phones and tablets. And a little bit lately, I went to the show in 2015. There was a lot of focus that year on self-driving vehicles. But in 2022, and I think to some extent in 2023, John Deere was one of the kind of featured companies. And the reason for that is not because the Consumer Electronics Show is considered to be a farm show. In fact, far from it. It's because John Deere and other companies that are working and innovating in this space, they want to get their technology known. They want to get it out there. They also want to make sure that some years down the road, if you're driving down a country highway and you look out into the field and you see an implement like this or a tractor like this with no driver sitting in the cab, tilling or chisel plowing or planting crop or harvesting a crop, and you see no operator present, we hope that will not be a shocker in the future. And especially, and this is probably a little bit further down the road in time, but especially as we begin to see some of these pieces of equipment also being operated out on the highway. Now, again, I think that's a little bit further down the road. And obviously, it's further down the road because of some of these safety issues and safety implications that we really need to work through in the future. If you think about some of these pieces of equipment now, what you see here with the John Deere tractor is fully autonomous, or it is an autonomous tractor. You see that there is no operator in the cab. Maybe I shouldn't use the word fully autonomous, but it is without an operator as it's doing its work. As we see these kinds of things, there is relatively lesser risk being out in a farm field, as is obvious, but as we begin to cross over more and more into the public domain, and obviously that's the highway, we're going to need to think more and more about safety-related issues. Also, as we see workers out in these fields, as I'm going to talk about in a minute with California, there are some concerns there as well from a regulatory perspective. Here's another quick example. This is from a conference I attended back in the latter part of 2022. This particular piece of equipment is a Gus sprayer. You see it's this metal body sprayer. The large cylinder in the middle is the tank. And this particular sprayer is designed to operate by itself. There is no operator's platform. It's not necessarily remote controlled, but it is guided by a combination of machine vision, artificial intelligence, machine learning. It's full of different safety sensors. Actually, a couple you can see in the front. There's like a bumper. It actually looks like a big handlebar. That's actually if a person does come in contact, or if the Gus sprayer encounters an obstacle, it's designed to stop. You also see that in the very front, it looks like a little bubble, a little eye. There are cameras, there are sensors. There's a technology called LiDAR. LiDAR is a sensor that is now being used on a lot of these pieces of equipment. And think of a LiDAR as like a radar, but instead of bouncing radio waves, as how a radar works, you're using light and calculating the distance for different obstacles and different things that may be that you may need to sense. It could be a person, it could be a fence post, it could be a dog, it could be a cow, whatever it might be. We need to make sure that this equipment is fully capable of sensing its operating environment, and then knows when to stop or knows when to take appropriate actions. And again, that's what a lot of my work is focused on as a safety specialist. Just to be totally fair and balanced here, I should also talk about the fact that all of the big agricultural companies are really moving quickly into this space. My most recent graduate student, Kelly, is working for CNH. Her title is, she's a functional safety engineer. And, 5 years ago, such a title did not exist. So people who are working in safety with these big companies are hiring people to work on safety-related, again, the LiDAR sensors and the artificial intelligence and the machine learning algorithms. But they also need to think about all the traditional safety-related issues as well with their traditional equipment. This is an example of a smaller, I guess we could call this a tractor. This is about the size of a picnic cooler, these smaller things that are able to do sort of garden or plot size operations, planting, tillage. And then we also see what I'm going to call or characterize as helper robots. So think about this. I think that the brand name on this is Burro. These are being used now out in California. It's basically a UTV, a utility vehicle or an ATV that is designed to operate on its own. And what we see happening is in the orchards or the vegetable, or could be fruit like strawberries in California, Florida, Texas, Arizona. Right now, what happens is often with workers, they will pick a basket or a bag full of produce, again, fruit crops, whatever it might be, and then they have to carry those containers back to the end of the field, and it's a very inefficient operation. And now we're beginning to see these self-driving vehicles, these self-driving UTVs that are able to go out, pick up product. It knows how to get to the end of the field. It's able to learn what fields look like. It's able to be remote controlled with a smartphone or an iPad. And again, we see more and more use of these kinds of things happening. Actually, accidentally skipped a slide. Coming back to it, I do want to just spend a moment talking about this technology. Another example of something that is able to operate fully independent of a human being, what this is a cover crop seeder. So think about this, again, about the size of a sort of a standard cooler that you might take with you, to an event or to a music festival or whatever. Weighs about 100 pounds, I believe, and this thing is seeding cover crop seeds for cover crops under a standing crop canopy. In this case, obviously a corn crop. You might ask questions about this, and when I've done presentations here around the country, I've had people sort of chuckle and grin when they see this. They think, "Oh, what's the seeding rate?" Well, good question. Seeding rate is probably on this somewhere between 2 and 5 acres per hour with the standard seeding rate. So you think, yeah, how am I going to possibly rip into a 200-acre field of corn with this little robot? So I'd like for you to maybe change your thinking and paradigm just a little bit. Imagine instead of an individual grower having one of these little R2D2 dairy or beer cooler size robots, imagine instead that you are a service provider. Imagine instead that you are a custom operator. Instead of you operating machinery, you drive up to the field and you have a trailer that is loaded with 20 of these units. And you've got all of your seed with you. You've got charging packs. You've got extra batteries. You've got your technology. You've got your tablet or your smartphone. And instead of you being out there operating as a custom operator or a service provider, you deploy your swarm of robots. These robots are able to talk to one another. You have total control. You can see which parts of the field have been seeded, which parts have not. The robots know this, and each robot, again, as I mentioned, are able to communicate between each other. And it really does change the paradigm considerably. So instead of you being the person driving this, you are the person managing a fleet of machines. And these machines are doing a lot of the work independently and autonomously. So that's actually a vision that a lot of people do have for the future, these smaller scale robots that you might not even recognize as something doing farm work. But in this particular case, it's doing a job that's quite important, but also one that can be logistically very difficult. So hopefully that takes away a little bit of the chuckling and grinning as you watch this. I want to maybe knock down a couple of other barriers as I talk about this. And one of these is people were naysayers back at the turn of the last century as we moved from the 1800s to the 1900s and we started to mechanize. People really didn't think it was actually going to happen. And it really did take a long time. It took more than 50 years. The number of tractors on farms did not actually exceed the number of horses until about 1954. My father, who was born in 1939, grew up farming with horses. He had access to tractors, but there was still a lot of work done on the home family farm with horses. I guess during the times he grew up, 1954 would have been right around in that time frame. So he saw a lot of transition from the early 50s to obviously the early part of the 1960s. The transition took decades, as I talked about. In this particular case, you see a sort of interesting mixture of horses and an old steam engine here, or I guess this is actually technically a tractor. And what you're seeing is not the horses pulling the tractor. The horses are actually trying to get the tractor unstuck. But the bottom line is you saw this interesting sort of mix of tractor power and machinery power for the first full half of the last century. It did not happen all that quickly. And the other thing that happened with all of this new technology is it received a huge amount of pushback. So again, you might be seeing the cover crop seeder, or you might see that giant John Deere tractor. I guess it's not that giant, but the big John Deere tractor pulling a tillage implement that I talked about when I talked about the Consumer Electronics Show. And you might shake your head and say, nah, it's not going to happen. We saw similar people having similar attitudes, again, all the way from around 1880 all the way up until the middle part of the 1950s. And one of the big concerns is that agriculture, if we get rid of horses, if we get rid of animal power, agriculture is never going to be the same. It's going to forever be transformed for the worse. It's what a lot of people thought. And the other thing that was of great concern is what will the impact be on local businesses? People who shoe horses, people who design or stitch harnesses and saddles and other types of things that were required for animal power. Well, what's going to happen to them? They're going to get put out of business. And we see the same kinds of concerns happening now. What about people who want to drive tractors? What about the local implement dealer who may not be equipped with all of this new technology? Well, the same questions happened decades ago. This transition from horses to tractors was pretty glacial. It actually was more glacial than we might remember, because what we started with was steam power, and then the steam engines were big and heavy and massive and would easily get bogged down. They weren't very mobile. But then we went to the lighter weight internal combustion engine. Throughout the 1920s and 30s, this is actually a picture of a 1937 John Deere A. So 1937, we're about 30 or 40 years into this. We're still using steel wheels in a lot of cases, in a lot of situations. And actually that was commonplace through World War II until after World War II, when we could really start looking at a lot more sources of rubber tires. And then we began to add other types of components, hydraulic systems, power takeoff power. And then we did start to think about safety. We started to think about lighting and marking and rollover protection, ROPS. As we moved toward the latter part of the 1960s and early 70s, then cabs became commonplace. And then during that time, we began to introduce different types of electronics, monitoring systems, control systems, those sorts of things. Now, let me just, again, pause for just a minute and say safety was part of this. Believe it or not, in the early part of the last century, people said, I'm really concerned about this from a safety perspective. I know my horses, they're predictable. These machines are big and powerful. And so there were actually the opposite concerns of what you might think about. The bottom line is in 1943, that's the year for which we have the oldest data here from Wisconsin. By the way, this is on my webpage, and I think I'll talk about that at the end of my presentation. 1943, we had 166 fatalities. That's that's 4 times what we have here today in the 2020s, 2019, 2020. But we also had a lot more farms. We also didn't have the systems that allow us to do some of those CSI style investigations. So my real guess is that number was probably in excess of 200 fatalities a year. Interestingly, though, about 20 were from horses, 18 were from tractors. So we had this sort of interesting, it's going to be kind of something we're going to have to deal with both horses and tractors. 7 were from bulls. But the bottom line is, as technology changes, it does change the nature and the characteristics of the safety-related hazards that we need to think about. In technology, I also want to just say we are in a similar time of transition now. Old picture here from an old planter monitor. By the way, this can be yours for the low price of $800. Pretty simple device. I would consider this more than an antique. Right now, if I took a group of students in our biological systems engineering shop, we took them down as part of a lab, they could actually build something like this in probably a couple of hours. And yet at the same time, back in 1966, planter monitors were revolutionary. We then moved from monitoring, shaft rotation, planters, those sorts of things. We moved into the 1990s where we developed GPS. We actually borrowed GPS from the federal government and the military, and that allowed us to do a lot of these precision applications that we think about now, monitoring, yield monitoring, mapping, variable rate application, and now we've got auto steer and other types of features. Also, we have self-diagnostics. If I'm milking cows with a robot, I'm going to get constant sort of text alerts. I can look at what's happening on the farm with my smartphone. Lots of direct machine-to-machine communications. So what I'm trying to tell you today is this stuff is coming. It is part of this natural progression of innovation that we've seen over the last century, almost a century and a half. But the speed, I talked about tractors. It took 50 years for tractors to overtake horses. The speed has accelerated dramatically in the same way that the capacity of my smartphone has increased dramatically in the last 10 years. If you've got a laptop computer, things are just increasing their capability at lower and lower costs in an exponential fashion. And because of the labor-related issues, they will be with us. Please mark my words. And I will tell you that if you're a person who is younger than me, I'm not going to be working in this area forever. You are going to have some major, major cool opportunities to work with this equipment. It's going to maybe shift the nature of your work, but it is something that is going to present lots of opportunities in the future. So do make sure, as part of I showed you the 12 things you can do now, make sure that you're learning about the things that are happening. Let's talk a little bit about safety. Safety is one of the other big benefits. We can save labor, and I'll talk about that in a minute, but we can also improve safety. I don't want to spend a lot of time on this chart or this particular graphic. In fact, I'm going to take myself off of it to say that this is what we call the safety hierarchy. The safety hierarchy basically says agriculture is a dangerous occupation, right? And oftentimes when we think about safety, we think about the lower part of this hierarchy. We put warning decals and we do training and we require people to use personal protective equipment. All of those are very important, but they are not as effective as the things that you can do to separate people from hazards. And we can do that either by eliminating the hazard through design, or we can use safeguarding devices. And ultimately, if we can design something so that you get rid of the hazard or the contact between the person and the hazard, that is ultimately going to be the most effective way to protect people, to protect operators, to protect workers. And that's really, if you think about it, that's what autonomy does, is you separate the person from the hazard. So if you think about that big Gus sprayer, that big stainless steel, that big steel, it's not stainless steel, that big steel sprayer that I showed you with the big cylinder in the tank, and that thing is out spraying in an orchard in Wisconsin or California, and you are able to separate the person from the insecticide or the fungicide or the other type of crop chemical or crop protection product. That is a really awesome way. You also eliminate the potential for rolling over and killing a person. And we've been thinking about this sort of stuff for just as long as tractors and other types of equipment have been around. How do you eliminate the hazard associated with a tractor rollover? Well, we build tractors that have a wider center, a wider baseline of stability. They have a lower center of gravity. The old tractors from the 1920s, 30s, 40s, and 50s had the narrow front end, and those tractors were super tippy. So we haven't eliminated the hazard associated with tractor rollovers, but we've designed equipment differently. And again, that's the direction that we're heading with these various forms of autonomy. Now, this is a little bit of a complicated slide, and so I want to only spend a little bit of time on this. We do have the potential to save labor. And this is a specific example from the Gus sprayer, where on a small operation, you may go, just as an example, from 2 workers working in an orchard. Again, in California, a lot of these equipment are being used in orchard situations, but we're going to see the same types of applications here in the Midwest. But you go from 2 workers to 1 worker with an investment in a piece of equipment like that big metal or steel sprayer. Where it becomes really attractive, or where it becomes much more sort of economically interesting, is when you begin to look at larger and larger businesses. And this is where we start to see some of the custom operators and more of the service providers, some of the benefits there. The little red box in the lower left-hand corner, on a small individual farm, you may see a 2-to-1 labor reduction. But if you begin to think about a mid-size application business or commercial service, you might see a 4-to-1 or a 5-to-1 reduction in labor. But again, you're going to have to spread that investment over a large number of farms to be able to justify the investment. So labor, kind of a big deal. Let me back up to this slide. What you are seeing here is a weeder. Again, out in California, this is something being done as a service. Now, let me just stop that here. Let me talk about what's going on here. So what you are seeing is a weeder that is being used in specialty crops. In this particular case, I think this is a cabbage field, if I'm not mistaken. So what you see now is one machine that is working in a field. This one machine is replacing 24 hired workers. It is being operated by a person who is walking behind the machine with an iPad, kind of monitoring things that are happening, but you have a 24-to-1 reduction in the labor needed to weed this particular field. By the way, what's interesting about this is all digital, it's all connected to the internet, it requires broadband. When the operator takes this weeder and it loads it onto a truck, moves it from field to field, if it is, for example, going from cabbage to romaine lettuce, there is a remote operator who is actually supervising a dozen of these machines located all over the country, and they are able to upload the right crop model, including plant spacing, row spacing, and all of the parameters that are needed to do this particular job. From an economic and from a labor perspective, what you're doing is you're taking a piece of equipment and you are removing the ergonomic hazards. This would all be work that would be done manually by hand with people, probably immigrant workers or migrant workers that would be carrying hose and other hand equipment. You have significant exposure to, obviously, sun, skin cancer, those kinds of things, in addition to the ergonomic related hazards. And you're replacing 24 of those people with one person. You're seeing an economic cost. Instead of having the crew of 24, the economic cost of $800 an acre going to $180 an acre. Now, I'm not going to go back and restart this video, but I also would like to note for you, you might look at this and say, how and why is this any different than something, I'm just going to talk from my own perspective, something that I grew up with. I grew up doing this sort of work in corn and soybeans with an old John Deere 630 tractor and a front-mounted cultivator. So this machine is essentially accomplishing the same thing between the rows, but because this new automation has cameras, machine vision, machine learning, and artificial intelligence, not only is it taking weeds out between the rows, but it's also able to weed between plants without taking out the plants themselves. It can recognize and differentiate between a cabbage plant and a weed, and those little shovels, those little cultivating devices, are able to move in and out with hydraulic actuators and actually be able to weed, again, not only in the row, but between plants as well. Another quick example to show you here. Hopefully this is communicating out and you're able to see the flashing, interesting sort of flashing lights that are happening. This is another weeder, and it is using, it's a laser weeder, so you can imagine it is using a laser. This is operating in a high density crop, in this particular case spinach. As it goes through, you see the little weeds, you see the little fireworks happening between the wheels of this, and that's actually the laser beam that is killing weeds. It's burning weeds using a CO2 laser. Probably not ever going to be practical for an individual farmer, an individual operator, but as a service, as a subscription service or a custom service, that's where this type of equipment shows great potential. I probably should mention, we do have a number of industries here that are prominent in Wisconsin that are interested in this sort of thing and how we might adapt this for example, to a cranberry marsh up in the central parts of Wisconsin. It's not going to be this machine in particular, but how might we think about these types of applications in the future? The other thing I should just mention from a safety perspective, you can imagine these new technologies they eliminate some safety-related hazards, but they introduce others. You wouldn't want to have a child or a pet out working near a CO2 laser, because obviously if a person or a pet or an animal got underneath this particular piece of equipment, it could do great damage and harm. So we have labor savings as a potential. We have potential safety benefits. I want to also just talk briefly about a few more things. The opportunity to reduce input costs and create a more sustainable situation. This is obviously a societal demand. All of these things are enabled and made available to us through high-tech sensors, machine vision, artificial intelligence. They can interact with individual units of production. So a robotic milker is going to recognize individual animals and can custom either feed or treat or care for that animal, also can monitor production. And then increasingly, we can actually look at things at the plant level as well. We are then able to only use resources, or only have to use resources like feed and pesticides and fertilizer and especially water in areas and situations where it is most needed. What else? These allow for 24-hour operation, nighttime work operations. It's potentially a solution for people who have disabilities or physical limitations. The other thing that I find interesting about these new technologies, it is probably going to be appealing for the incoming generations. It is probably something that we're going to need to think about, whether you are a custom business or you are a farmer, in terms of succession and looking at bringing that next generation in. And again, as I've talked about, it could perhaps be the only solution in those areas of the state or those areas of the country where you're having difficulty finding workers. So you can probably gather from my presentation, I'm a little bit of a sort of a technology evangelist. I want to be careful with that, though, because there are a lot of headwinds that we really do need to be thinking about. And just like that transition from horses to tractors, things are not going to happen easily. They are not going to happen overnight, and we're going to see fits and spurts happening. In my work, because of my focus on safety, when we talk about automation and we talk about sensors and machine learning and artificial intelligence, it is a whole different world. Yes, we are designing out some of the hazards consistent with that upside down pyramid that we call the safety hierarchy, but we also need to be thinking about what types of new hazards might we be introducing. We typically do that with a process that engineers go through. I actually teach it in the classroom, called risk assessment. And with risk assessment, you look at things that have happened in the past and you make sure that you apply the appropriate types of design principles and design standards so that you improve the safety of the system that you are inventing or designing. The problem is risk assessment requires data. And with brand new forms of equipment, we simply don't have that data. I've done 150 of those CSI style investigations on tractor rollovers and power takeoff entanglements, but I've not yet done one on a robotic injury or fatality. I don't know that there have actually been any, but in the future there likely will be. And so the question is, how do you assess risk in an environment where you don't have a past history? That's really a big focus of the work that I do. And it is also, not having that data is actually something that is creating a bit of a barrier. So risk assessment requires data. And what about the new hazards associated with artificial intelligence? We don't always know exactly how these machines are going to operate. Because we're talking about them constantly learning new things through machine learning and then the applications through artificial intelligence, it's going to take a while before we're able to fully understand the safety implications with this new equipment. The other thing that I am working on in my research work and my collaboration with people around the country is, what about the situation where we have on a farm, we have some highly automated or autonomous equipment, and then we have traditional equipment. It is a real issue with workers, with training, especially if we're bringing in young people. We also need to think about things like certification programs. Like, how do you develop a full-scale certification program for operation and safety when we don't yet have the experience with these types of new innovative technologies? Let me just turn this off for a second. So one of the places where this is playing out is in the area of regulation. And in particular, regulation in California. California, as I say in this slide here, is the space to watch. Even here in the Midwest, there was a big California OSHA board vote where they denied a petition to allow autonomous tractor operation. And their rationale as a board of directors was based on an old 1970s regulation that said that there needed to be a person on board a machine as it's moving through the field at all times. They also talked a lot about this need for data. This is not a new thing. When you talk about regulation and regulatory requirements, regulators need data. And so again, from the standpoint of my research work and looking at these, we're trying to get the data that will help not only industry, but also insurance companies and other people, including regulators, to make sure that we're doing things in a smart way, that we don't somehow slow down the application and adoption of these opportunities. We also need to be thinking about other types of risk, autonomous risk. When we talk about autonomous spreaders and applicators, I think probably right within the wheelhouse of a number of you who are watching this, we need to think about the impact on the environment. What happens if we do have an autonomous vehicle that spills or overturns or rolls over? We know from the work that I've done with my graduate students that human operators, even experienced human operators, do make mistakes. They do occasionally fail. And so this new software, this new artificial intelligence needs to be at least as capable as a human operator. And then finally, we're going to have to eventually think about highway application. A lot of related issues. Because my time is a bit tight here today, I'm not going to spend a lot of time on these. We do worry about also cybersecurity. Thinking about what happens if we have a machine that goes down, either intentionally or unintentionally. Diagnosing and repairing a software-based piece of autonomous equipment is totally different than the idea of manually replacing a ruptured hydraulic line or, changing the oil in a vehicle. It is going to require a whole different degree of skill and training. And again, I do think that it presents opportunities for people who have a vision in this area. We also are quite concerned about broadband access. Still in Wisconsin, about 20% of our farm operations have significant parts of the farm where you don't have broadband access, either through smartphones or hardwired internet. I know that there's a lot of talk about Starlink as a potential solution. I would caution you just a little bit. Starlink requires Starlink is not good for mobile use, and so I think it is something that we're going to have to continue to push on broadband. Also, we know that farmers are quite concerned about data. They're concerned about security. They're concerned about privacy. And if you look at these data, about 54.5% of our farmers, even without having autonomous equipment in the equation, they are concerned about their comfort level of being able to keep up with new forms of technology. This is an issue on the farm. It's also an issue for ag service providers. When we surveyed ag service providers, we found that over 50%, 39 plus 19, so that's 58% of our businesses say that finding people with agricultural technology expertise is a moderate or significant problem. Also, being able to attract people to work within their community within those skills or with those skills is also problematic. A quick couple of notes. I do think that I've got different lighting here because the sun is now coming into my windows. We do know that this is a great potential opportunity for our technical colleges to hopefully fill some of these gaps. They often have strong agricultural programs as well as programs in manufacturing and technology. Probably the most important thing from my work thus far is we need trust. Trust is a safety-related issue. We need worker trust, workforce trust, community-level trust. We need to be involving farm workers. This is a young man who I met from California, from the California Farm Worker Foundation. Talked to the upper right-hand corner, farmer that was trying to pilot some new machinery with no farm worker input, and it failed. He talked about the fact that these workers, and you might be in this mix of people yourself, you guys know the work, you know the fields, you know exactly how to do the work. So we need to be having conversations, and that's part of trust. As Hernan Hernandez said in the lower right-hand corner, technology in the 21st century, it is critical to solving some of the most present concerns for the ag labor sector, also helping workers obtain economic mobility and obtain a safer work environment. Economic trust is also going to be important. Trust between farmers, workers, engineers, investors, technology gurus, as I mentioned earlier. Deciding to more fully automate and invest in technology is not like deciding to spend $9.99 on a new smartphone app. We need case studies. We need economic analysis over a multi-year period. We need other data, documented testimonials that represent the diversity of agriculture, geographies, regions, climate, those kinds of things. Final thing that I'll say from a safety perspective is we have to do this right. There's a person named Peter Sandman. Sandman talks about how risk includes not only reducing the probability or the severity of an incident, it also is about a concept that he called outrage. And what happens is if you have things that are kind of industrial versus natural, or exotic versus familiar, or unknowable versus knowable, when something bad happens on a piece of equipment, just as an example, that is considered industrial, exotic, and unknowable, that could be that stainless steel sprayer that looks very industrial, it looks rather exotic, it's not very familiar to us, and if it's being operated by machine learning and artificial intelligence, it's not always fully knowable. Those are situations that could result in a huge amount of outrage, which could actually serve to sort of cripple a project or technology. So from a safety perspective, the advancement of new technology is very dependent on our ability to do it at a level of acceptable risk and acceptable safety that is acceptable not only to the farmers and the ag service providers, but also to the general public. And then finally, I want to just say in conclusion, this is from JFK, where he talked back in the early part of the 1960s about sending a person to the moon, and getting them back safely, by the way. So safety was a big part of this challenge. We have a similar challenge today of feeding 10 billion people by the year 2050. And technology is absolutely going to play a crucial role, but it is one that we have to be done right. And it has to be done with a degree of trust and safety that's demanded by society. I will also just say, for those of you who are worried about maybe you've missed out on this big wave of technology, if you think about 1961 to when we actually landed Neil Armstrong on the moon in 1969, I'd say we're probably at about 64 or 65. So there's still a long ways to go. There's still a huge amount of opportunity, but only if you think about the opportunity and frame it from the perspective that you are working in an industry that is amazingly important, that is going to change, and with change often comes opportunity. My last slide, and then I will sign off, is if you are interested in this work, or other work like it, including the work that I also talked about in another video on farm stress, I do encourage you to check out my website. It's agsafety.wisc.edu. With that, I would like to thank the organizers of the symposium and the other events connected to this, and would love to hear from you if you have any questions, comments. Check the notes below the YouTube video, and I will look forward to seeing you another day.